Hey everyone, Mr. Armitage here. In this video, we're actually going to be doing something different. Decided to go over the check your understanding questions for the assignments we do. So maybe, right, you can actually check your understanding. Okay, so this one here is what was the real average of the Unit 4 C6 test, right? We took four we took 4 samples of 5 scores each and put them up on a dot plot, right? You can check OneNote for that image. Okay, this was done on March 7th. Okay, so let's look at the check your understanding. Okay, pennies made prior to 1982 were made of 95% copper because because of their copper content, these pennies are worth about 0.0265, so 2.65 cents each. Pennies made after 1982 are only 2.5% copper. Jenna reads online that 13.4% of pennies in circulation are pre-1982 copper pennies. Jenna has a large container of pennies at home. She selects a random sample of 50 pennies from the container and finds that 11 are pre-1982 copper pennies. Does this provide convincing evidence that the proportion of pennies in her container are pre-1982 copper pennies, or that the proportion of pennies in her container that are pre-1982 is greater than 0.134? Okay, so first off, we have to identify the population, parameter, sample, statistic. Okay, well, the sample is super easy. Okay, the sample is usually the easiest thing to find in these descriptions because it's just going to be what we randomly sample, right? A random sample of 50 pennies. So that's our sample. Okay. The population we took that from were all the pennies in the jar, right, or the container. Right, we took our pennies out of this container, so that container is the population. Okay. Now the statistic is actually decently okay to find, right? 11 are pre-1982, right? So our proportion of copper pennies in our sample, 11 out of 50, or 0.22. Okay. Now our parameter, here we actually have a value, okay, because this is the true proportion of pre-1982 pennies, okay, which we know is 0.134. Okay, we actually have that. Now, does Jenna have some evidence that more than 13.4% of her pennies are pre-1982 copper pennies? Yeah. Yeah, she has some evidence. Okay. Yes, because her sample is greater than 13.4, so there's some hint that it might be. So sample had percent, which is greater than 13.4%. Right? Now, okay, provide 2 explanations for this evidence. Okay. Well, the actual, right, we have 2 reasons, 2 ways this can go. Okay. The first way, it's totally possible that, okay, she just got her sample due to random chance. Okay. Okay, sample variability. Okay. Which is really just to say that the sample was lucky but the actual percentage is actually 13.4. Okay. Just by complete random chance, her particular sample got more than what we expected. Okay. Now the other reason, okay, and this is the one we're interested in, right? The percent in the container is actually greater than 13.4%. Greater than 13.4%. Okay. So how do we distinguish between these two, right? How do we distinguish between just sample variability, getting lucky in our sample, and actual evidence that, something funky is going on, right? That actually our container does have more than 13.4%. Okay? So we use technology to simulate selecting 100 simple random samples of size n equals 50. So we took 100 samples of size 50 where we assumed, right, from a population of pennies in which 13.4% are pre-1982 copper pennies. Okay, so here we are assuming that the actual proportion is 13.4%. Okay, now we don't know if it is, but that is our assumption that it is. Each of these dots represents one sample. Okay? So we have one sample here that's less than 5%. Oh, another sample less than 5%. Okay, so there is one dot on the graph at 0.22. Okay, so that's this one right here. Okay. Explain what this dot represents. Okay, so that dot is one sample. One second. Change something. There we go. Now each sample had 50 pennies. And its location tells us that 22% of those 50 pennies were pre-1982 copper pennies. Okay. We had our description come from our result. Sorry, we had our answer come from the description of the problem, right? Sample of 50 pennies. Each of these dots represents a sample, right? So assuming that 13.4% of pennies in circulation are pre-1982 copper pennies, okay? So assuming that the 13.4% is true, okay? Obviously Jenna had to get these pennies through, we will say legitimate means, hopefully. Okay. Is it surprising to randomly select 50 pennies for which the proportion of them of being the pre-1982 copper pennies is 11 out of 50, or 22%, or greater? Justify the answer. Okay. Well, if we look at our result, that's the 22 there. Okay. 22% or greater. Okay. So this part here, Jenna's result. Okay. This particular one right there. Okay. But here we only have 4 dots. Okay. 4 dots out of 100 dots total. So assuming that this is true, yeah, it's very unusual to get this particular result or greater. Okay? We don't expect that to happen because it should only happen 4% of the time, according to our simulation. 22% or greater. Okay, right, that 4 out of 100 is 4%. Okay, so based on our previous answer here, okay, is there convincing evidence now that more than 13.4% of pennies in the container are pre-1982? Yeah. Yes. Okay. Right. If we assumed, we were assuming, okay, that 13.4% were copper, our particular result would only happen 4% of the time, which is unlikely. Okay. Only 4% of the time would we actually get that particular result with a sample of 50 of 22 or 22% or greater. Okay. And that's the basis of sampling distributions and using it to determine if we have evidence for a claim or not.